Welcome back to MatheMagics, everyone. We're going to start off by reviewing that word problem I left you with last time. So we have a traffic sign and we want to find the area in square inches. And the length of my traffic sign is 24 inches by 24 inches. So we are looking at a square. I want to multiply those side lengths together to get my total area. And if I rewrite in exponents, that would be 24 squared. And then I just need to do the multiplication real quick to figure out what that is. I get 96 for multiplying by the 4. I add my 0 and then multiply by the 2. And then I'm going to add these together and I get 576 square inches. And to tackle the bonus question, we want to find the area in square feet. So I want to convert these measurements into feet first. And as we know, from measurements there are 12 inches and 1 foot. So if I have 24 inches, that's 2 feet. So my measurements become 2 by 2, which is the same thing as 2 squared, which is 4 square feet. So those are my two answers, 576 square inches and 4 square feet. Moving right along to today's lesson. As promised, we are focusing on the order of operations today. And before we get to any example problems, there's a few things we need to talk about first. First off is that order of operations is used when we have numerical expressions. And to understand what that means, expressions contain only numbers and letters. That means that there are no equal signs involved. If there was an equal sign, we'd be dealing with an equation, and equations involve slightly different tactics in order to solve them. So expressions will have no equal sign, and we'll use the order of operations to whittle them down and find out what they actually become. The other thing I want to talk about in terms of the order of operations is that many of you have probably seen before the phrase PEMDAS, if you've ever learned the order of operations, which stands for parentheses and then exponents, which we just talked about, so something like 2 squared. Then we'd have multiplication and division, and then addition and subtraction. Whoops. And to do the subtraction symbol there. I have been talking for years about how I really dislike this P here that stands for parentheses, because the truth is that it's not always a parentheses that symbolizes what we need to be doing first. I've been trying to get it changed to a G, and when I say try to get it changed, I mean I've just told the few students I've worked with, because I think it really needs to stand for any sort of grouping symbols. This does include parentheses, but it's not restricted to parentheses. And then it also includes things like brackets, which you'll see from time to time, especially if you have parentheses inside of brackets. And the other thing that grouping symbols can relate to is actually when you have a fraction and you have something on top and then you have something on bottom. Each of these two separate things are actually their own group, and they need to be dealt with individually before you deal with the fraction symbol, which, as we've talked about before, stands for division. So each of these are in their own group without having any sort of parentheses or brackets on them, and therefore have to be dealt with individually. So I feel like GEMDAS is actually more appropriate for order of operations instead of PEMDAS. It includes more of what we'll actually see in problems, because we are not always going to be restricted to just parentheses. The other thing I'm not a big fan of when it comes to order of operations is whether we're talking about PEMDAS or GEMDAS. It's usually written in a horizontal order, implying that this must go first, then this, then we do these, and we finish off with the addition and the subtraction. But really, I think it works better in a vertical setup, because, I'll tell you why in a second, when we're writing out what each of these things stand for, so my G is for my grouping symbols, the E is for exponents, the reason why multiplication and division is grouped together is because we do not always do multiplication before division. We actually have to do them in order from left to right. So the division could actually be coming first as we're reading the problem. And this up here implies that I should always be doing my multiplication before my division. And that is not always the case, and actually will get you the wrong answer if you're always following that rule of thumb. And the same thing applies to the addition and subtraction. We actually want to do them at the same time in order from left to right. So that may mean that you do some subtraction before you do any addition, but that's okay because it's actually what we're supposed to do. I'm not running out of room. Ah, just made it. All right, now let's look at some examples. So we're going to start out pretty basic, and we're going to, what is going on? Okay, and we're going to become more complicated as time goes on. So again, I'm just going to write it up here just to have for reference as we are solving these problems, GEMDAS. I have no grouping symbols in my first question, 12 minus 2 times 4, and I also have no exponents. So I go straight to multiplication and division, and I do have some multiplication right here, so I'm going to do that first. Notice how I rewrite the whole problem with just the one thing that I've changed so far. No more multiplication and division, now I've just got some subtraction, so I go ahead and do that. My answer to this is 4. And when we're solving these, what we're doing, and what you'll see if you ever work on this on a worksheet or a test, it will tell you to simplify the expression. Notice it doesn't say solve. Solve is for equations. Simplifying is for expressions. And now you know. All right, problem 2. We've got 7 plus 60 divided by, in parentheses, 3 times 4. So I've got myself a grouping symbol, so I need to do that first. I'm going to rewrite the whole rest of the problem, and I'm just going to change that 3 times 5 into a 15. I've got no exponent, so I go straight to the division that I see here, and now this becomes 7 plus 4. Finish off with the addition. My simplified expression is 11. Continuing right along, getting a little more complicated now. Let's try and center that on the screen. So again, GEMDAS. Start with grouping symbols here. I've got 30 divided by, in parentheses, 7 plus 2 to the 3rd power times 6. So I want to start inside my parentheses here, inside my grouping symbol. And inside here, I'm going to start with the exponent, because once you're inside the grouping symbol, you still follow the rest of the order of operations. So 2 to the 3rd power is 8. Notice I'm still keeping the parentheses because I haven't finished everything inside there yet. And that's what I'm going to finish off with next. 7 plus 8 gives me 15. All right, so here's that situation I was talking about. I'm up to the multiplication and division step. Notice my division comes first. That's okay. I have to do whatever comes first as I'm reading the problem from the left to the right. Just like if you were reading a book, you read the words in order. So we are going to start with the division first. 30 divided by 15 is 2. And then I finish with the multiplication. 2 times 6 is 12. All right, one last one. And this is because I wanted to demonstrate one more thing you might see. We've got 9 plus 7 in parentheses 5 minus 2. So I start with my grouping symbols. And then 5 minus 2 gives me 3. Notice I kept the parentheses. The only reason I did that is because there's nothing in between this 7 and the parentheses right there. And this is a universal symbol for telling us we need to multiply. Multiplication is the only operation in math where sometimes there is no symbol used. So sometimes you don't see that times symbol, or later when you start writing multiplication with a dot, sometimes there is no symbol used for multiplication. And this is that situation. When you have a number in front of a parentheses, that is always implying multiplication. So that should be the next thing that I do here. So 9 plus 7 times 3, which is 21. Finish off with the addition, and now I get 30. Now it's time for the word problem of the day. So I've got a solar system model going on. We're buying foam spheres, paint bottles, and wooden rods to construct the model of the solar system. We want to figure out what is the total cost of everything. So if we look at this table over here, I've got 9 spheres. Each of them is costing $2. I've got 6 paint bottles, each costing $3. And 8 rods, each costing $1. I do want to point out something real quick here. I only have 9 spheres. That includes the sun and the 8 planets in our solar system, since Pluto, poor Pluto, doesn't really count anymore, even though our astronomers have officially said it's now a dwarf planet, but still not counted as one of the planets of our solar system. Anyway, so I want to set up an expression to get all these costs together. So for the spheres, starting with that, I have 9 of them, and they cost $2 each. So it's the same repeated amount, so I'm going to be multiplying. And then in addition to that, I've got 6 paint rods, each costing $3 each. And then I've got 8 rods, this was paint bottles, 8 rods, each costing $1 each. So here's my expression where I'm going to be using my order of operations. So I'm going to start with all of this multiplication. Since it's all separated, I can feel free to go ahead and do it all at the same time. I don't need to do it one step at a time. But if they are all jumbled together, you do want to take it slow, do it one number at a time. So 9 times 2 is 18. 6 times 3 is also 18. And 8 times 1 is 8. And now I can go ahead and just do all of this addition. 18 plus 18 gives me 36. And then I add another 8 to that, and that's going to give me 44. So it's going to cost me $44 to build the model of the solar system. Going right off of that, your turn to go ahead and work out a word problem for me. You need to read 20 poems in 5 days for an English project. Each poem is 2 pages long. Write and evaluate an expression, so no equal sign, to determine how many pages you need to read per day. So again, set up the expression first, just like I did with the solar system model problem. Separate out what you need to do first according to the order of operations, and then simplify it down until you've just got one number remaining. Thanks for sticking with me till the end again. Good luck on that word problem. I will be back soon with the next video to give you the solution to that. And we're also going to start working on factors and divisibility rules. Basically, I'm going to teach you some tricks so you can figure out what numbers will divide into each other without actually having to do the division. Thanks, everyone. I'll see you next time. Bye.